Funky friends, it's Professor Gallagher, and we're going to groove into CircuitPython by learning how to improve our code dramatically by writing functions. To paraphrase his royal badness prince, dig, if you will, our source code. Let's get down with some big learning. So Codemeisters, plug in that Pico and spark up the PyCharm. And if you're new to the playlist, here's where you can find all the goodness that brought us to this point. Now, at the end of an earlier lesson, we wrote some code that ended with us flashing each color in the RoyGBiv rainbow for half a second on and half a second off. We named that code RoyGBiv Pico Flash with each color off.py and saved it to our CircuitPython school folder. So I'm going to go and open up that code with the File menu, Open, navigate to the CircuitPython school folder, select the name of that file, open it. It opens up in a separate tab. I'm going to select all, copy it, then close this tab by clicking on the little X. Now I'm in code.py, which is on my CircuitPy board. I'm going to select all here and paste my copied code over this. And if for some reason you jumped to this lesson or you lost your earlier code, I've got a GitHub gist link in the description that has the same code so you can copy it, paste it in here, and dive in right away. Now, if we look at the code that we wrote in the previous lesson, we see that lots of the code that we wrote is identical or nearly identical. Look at this bit here. After we fill in the neopixel color, we repeat these three lines here, time sleep color pause, strip fill black, and time sleep off pause 7 times, one for each color. And if we look above this, the only thing that's different about the line where we fill in the color is the color itself. So that's 7 chunks of multi-line code that are identical except for a single color. And I want you to note how long our code currently is. Now, I've got some spaces in here, but the last line of my code is 59. Now, after we create our functions, we'll see that our code is much shorter. Now, lots of repeated code like this is not a good thing because there's a principle in programming called DRY. D-R-Y. Don't repeat yourself. Repeating in programming is bad. Repeated code is more difficult to maintain. The more places you need to make updates means the greater chance of errors. You could make a change in one place and not another when you mean to make it in both. And if you need to use this chunk of code again, say you decide to flash even more colors, you'd be writing more code instead of just calling a reusable chunk of code. So let's write a function. A function is a reusable chunk of code that we can call anywhere whenever it's needed, and this will let us stop repeating ourselves. Creating a function is referred to as defining a function. So we're going to start by using the def keyword. This says we're defining a function. Then we give the function a name. We usually use lowercase snake case for function names in Python. We follow this with parentheses. We'll start first with a function with no arguments, and we'll add arguments later. And add a colon after the parentheses. And the code indented below the function definition line will be part of the function that's executed when it's called. To call a function in your code, just give the function name followed by parens and any parameters, and it will immediately jump to the function and execute all of the code in the function body. Now in Python, functions need to be created before they're called. We're going to define it above our while true loop, but outdented even with the while true loop. We'll start with the keyword def space, then we'll call this turn_off. We'll add parentheses, initially passing nothing between the parens arguments. Sometimes those arguments are called parameters. We'll end this with a colon, function defined. And notice when we press return, we have lines indented. So just like our while statement, the items indented below the func are part of that related block of code. And when called, this function is going to stop running at the first line of code that's outdented at a level even with our function definition line. And then why don't we highlight these 2 lines of code that are repeated, the strip.fill black and the time.sleep off pause. Cut it out with a Command X, Control X windows. Then I'll paste it below the function definition. Make sure your indentation is right. Remember, Python is very fussy about indentation. Get it wrong and your code won't run. Now, the way we call the function in our code is we just refer to the function name passing in any arguments. If there are no arguments, you still need to have those parentheses. So I'll first add it where I cut out the 2 lines of code that are now part of my function, and watch what happens as I start to type the name of the function. TUR for turn off, and we see code completion knows about this function. Nice, just highlight it, press return, code completion enters it, and even includes the parens. And here's something to watch for. When you define a function in Python, you end the line with a colon. But when you call a function, there's no colon. There's just the function name with parentheses. As a general rule in Python, if a line ends with a colon, the lines that follow should be indented. The indentation groups those lines as a block of related code. You see that here in the function definition. The colon tells Python, here comes the body of the function. And you also see that with loops like while true colon. The colon here means, here comes the code that will repeat. Now I want to replace all 6 remaining occurrences of strip, fill, black, and time sleep off pause with a function called turn off. Now I could go through and replace this 6 times, but for those using PyCharm, let me show you some more efficient PyCharm goodness. Now I've highlighted the 2 lines I want to replace. Under the edit menu, there's a find option, which pulls up a submenu for find and replace, or I could pull up the find menu with Command F Mac, Control F Windows, which I'm doing now. Now look what I get. A find box at the top of my editor that already includes the lines that I highlighted in my editor. Nice! But I want to replace, not just find, so I can type Command R, Control R on Windows. A second box pops up below the find box, and this is where you can enter the text that you want to use to replace your find text with. Now, one thing that's really important when using find and replace is you want to make sure if you click replace all that you really want to replace all. I don't want to do that here because if I replaced all, I would replace these 2 lines inside my function. But you can exclude lines from find and replace. This is how you do it. Simply highlight any lines you want to exclude from find and replace. I've already done that. These are the 2 lines highlighted in blue. Then click this exclude button. You'll see that there's a strike through indicating that this will not be replaced. And now I want to enter the code that I want to replace the 2 find lines with in my replace box. I'll just highlight the turn off function call here with its parens, copy it, and paste it into my replace box, then click replace all, and now all of those repeated blocks of code are replaced with a function call. Nice! Well, almost nice. There's one more issue. I didn't add a tab character in front of my replacement code, so it's outdented, and that's not good. All of the code that's inside while true needs to be indented. My while true statement will actually stop at the first outdent, and we don't need the find replace box for this, so I'm going to click in the X in the upper right hand corner, and that area goes away. Now I could click 6 times and manually add tabs, but let me show you another PyCharm shortcut. I can enter multiple cursors that will allow me to type the same thing at multiple spots in my code. Now I've clicked on the first place where I want to add a tab character. That's in front of this first turn off call here in the while true loop. But on the Mac, I'm going to hold down the Option key. On Windows, hold down the Alt key. And I'm going to click every place where I want to also add that tab. So in front of all of these different calls to the turn off function, I'll Option click or Alt click on Windows, and I've now got 6 cursors, 6 typing points in my code. If I type anything like tab, whatever I type goes into my code 6 times at the 6 multiple cursor points. Ultra cool! And to get out of multiple cursors, just click anywhere in your editor. Now, if you're new to coding, it's important to understand what's happening with a function. So let's look at all of our code. Our code starts up here. When our code is saved or when we plug our board in, we start running with the very first line, which is a comment. But then we import our libraries, we set up our color variables, we set up the strip, we turn off all the lights, we set up the variables that hold pause times, and then our function is defined. At this point, CircuitPython recognizes that there is a function, so we can refer to this function name in our code, but it doesn't execute the code after the function definition. It just holds on to the knowledge about this function, and it knows if we call the function, this is where it can find the code it's got to run. So it can jump here if we ever make a call to turn off. Now at this point, none of the code here executes, but we do execute everything outside the function. So outdented below the function is this print line. We print this once before we hit the while true line, and remember, in while true, everything that's indented here will be repeated over and over again. So first we turn the strip to red, we pause for half a second, remember we define these variables up here, then we call the turn off function, and here we jump up to our function definition and we execute the lines indented below the function. We turn the strip black, we wait for half a second, and then when we're done, we don't execute the line below the function. This is the outdented print line we already printed here. Instead, we jump to the line below where the function call was just made. For us, that's fill orange, so we're going to fill orange, sleep, then call turn off again, which means we jump back up here, we run these 2 lines, then we jump down to the line below where we call the function. Now we're going to fill the strip with yellow, and we continue through the end of the indented code here, where we turn things violet, wait, run the turn off function, and when we return, since we're at the end of all the indented code in our while true loop, we start executing again with the first line indented below while true. So you see how functions work? we define them before they're called in our code, but we don't actually run the code until we call the function in our code. Then each time we call the function, we jump up, we run all the lines that are indented below the function, then when we're done, we jump back down to the line after where the function was called. That's how functions work. Now at this point, you can open the terminal, launch TO, save your code, and you should see your code run just as it did before. You're going to get the rainbow flashes. We saved a few lines of code with this function. We took out some areas where we were repeating ourselves, but we can do even better. So let me show you how we can write an even better function by adding a parameter. So we've just written a function with no parameters, but we can make this better. We're going to add a parameter to our function that lets us pass in a color into a block of code. Now whatever we pass in as the function call will go into the parameter, so here I can enter a parameter named color, and now if I make the function call, I need to include a value for color or else I'll get an error. So whether we call this with red, blue, or indigo, whatever I pass in with the call will be used by the function in the color value. In this case, using it so that I can strip.fill that color. Awesome! Let's update our function. First, I'll give this function a better name. Since I'm going to flash a color, I'll call this flash_color. And by the way, we see a bunch of red squigglies of anger everywhere we had the old turn off function call. Now, since that function doesn't exist, I just got rid of its defined name. Those errors are an undefined reference error. That's because the function name turn_off is no longer defined. That's Python's way of saying, hey, I don't know what this turn off is. But we'll fix that. But first, let's finish the function by adding a parameter. And again, we can call the parameter anything, but in between my parentheses here, I'm going to add a variable name that I think makes sense. I'm going to call this color, since we're going to use that to accept a color value, which is a set of parentheses with RGB values for the color. And in my updated function, I also want these two lines down here where I strip fill a color and I time sleep color pause. So I'm going to cut those lines out and I'm going to paste them in as the first two lines indented below my function definition. And now I need to make sure that the color that I pass in as my parameter here is going to be used inside the function. I no longer want to strip fill red, I want to strip fill color. So be sure to change red to color, and now any color I passed in will be used to strip fill that color, and now I need to replace all my old function calls. So if I delete this first turn off and start typing flash, look at this. Code completion knows this function was defined, even though we added it. It wasn't something built into CircuitPython. PyCharm is that smart. It offers it as an option, and if I press return, it puts my cursor between the parens so that I can add a color parameter. I'll type in red in all caps. And I need to do this for the other 6 colors, so I'm just going to copy this line here, delete all the old function calls, paste this in 6 more times, and then change the color to orange, yellow, green, blue, indigo, and violet. Those variables I defined earlier in my code, I set them to the parenthesis RGB values that we need for colors in an earlier lesson. And friends, look at this. My entire code.py file is now just 38 lines long, when it was previously 59 lines long. We're adhering to DRY, don't repeat yourself. We saved ourselves a ton of code by writing a function with a single parameter. By the way, what we're doing here, by changing our code to make it more efficient without altering the underlying results, is called refactoring, and you'll hear that term a lot in programming. Let's change the comment in the first line to the name I'm going to use when I save this to my CircuitPython school folder on my computer. I'm going to call this funcroygbib.py, and I'm going to copy this name and paste it into our print statement so I can get a print confirmation that the code is running in TO. And then before I save, I've got to open my terminal. I'm currently at the command prompt. I want to be in TO when I run my code, but if I up arrow, I can find the command that I last entered when I got into TO. Terminal writes this for me. I haven't plugged my Pico into a different USB port, and I haven't added a USB adapter, so this line should still be accurate. I'll press return. I can see in the output I'm connected to my plugged-in board. Nice! I'll click in my editor and save my code with Command S, Control S in Windows. Remember, in PyCharm, that's how we save and execute code on our CircuitPy board. We're not going to use this run button up top. And my code is flashing away with my console saying funcroygbib running. Nice! 1 parameter function skill acquired. Now let's close the terminal and save this to our CircuitPython school folder. I want to use the name in the first comment that I put up here, and I'll copy that, then select File, Save As, click these three dots. Some people call this the horizontal kebab or the meatball menu. I'll navigate to my CircuitPython school folder, click open, and now I see the to directory field below the file name is the folder that I just selected. That's where I want to save things. I'm going to change code.py to the name of the file that I want to use for my backup. And by the way, you can also pull down the downward pointing arrow here next to the directory name and select any directory that you've used before. So if you're using a folder you've used before, you can just pull down here and select it, like the CircuitPython school folder here. That would avoid you from having to click on the meatballs and select the CircuitPython school folder. Click OK, and a backup copy is now saved to our CircuitPython school folder on our computer, and you can see that we've got a tab up top with the name of the file that we just saved. Now, very important. Remember, the underline below this tab says that this is the active tab, and this is the file that's on our computer. If you forget to close this tab and start making changes inside this file, you're not changing code on your board. You're changing the backup file that's on your computer, and that won't run. I've got to tell you, I've wasted so much time because I forgot to close this tab, and I started making changes in this tab's window, changing the backup file, and then I'd save it, and I'd wonder why I'm not seeing those changes in the console or on my board. This is not the code on your board. So after performing a save as, it's always good practice to remember to close this tab. Just click on the X up here in the tab, so you return to your code.py file. That's the file that's on your CircuitPy board. Hopefully you'll never have this problem, but I've got to tell you, this is an error that I continue to make when I work too fast. Now, one more thing I'll point out, it's pretty basic, and you might have figured this out already. In the way that we've added a single parameter to our function, well, you can add multiple parameters. Just include them between the parentheses with a comma separating the parameters when you define your function, and make sure that you pass values into those parameters when you make the function call. If I made the changes that you see here, this would allow you to change the duration that the color shows and the duration that the lights are turned off with each function call. And if you did that, you could delete the color pause and the off pause values that you entered earlier in your code, since these are now values that you pass into your function call. You can try this out if you'd like. We'll use multiple parameters as well in future lessons, but you should also bask in the glow of acquiring more big learning. We learned about the dry principle, don't repeat yourself, and why functions are better than repeated code. We created a function with no parameters, a function with one parameter, and learned how to add more. We now know about the concept of refactoring, and we radically refactored our code, and there'll be even more refactoring that we can do when we cover loops and lists. So stay tuned, and we learned some super useful PyCharm tips for find and replace and working with multiple cursors. Now, this was only part 1 of learning about CircuitPython functions. There's a lot more to come. Stay subscribed for more groovy goodness. Your likes and comments will help goose the YouTube algorithm so that this content reaches even more learners. It also keeps me motivated to post more lessons. Continue to hack.